this is where it gets a little bit challenging, okay? And you gotta watch for this. So that's why we're teaching this kind of in two parts. The first part is the type 1 stuff. That's everything that we've been doing. That's the easy stuff, okay? Those are the ones where you don't have to worry about what charge they have. You just write the name just like it is, put an IDE at the end, and you're good to go, okay? The transition metals are a little bit different, okay? The problem with all of these elements in the middle, okay? Now you guys know where the transition metals are, right? What's the other name for the transition metals? Do you remember? Well, no, the alkali metals are actually on the far left side. The transition metals, remember, are the ones that are in the very middle, okay? So they're also named based on the orbitals that get filled in the middle. Do you remember what? Block? It's the D block elements. You guys remember that? Okay? Those ones in the middle fill D blocks. So here's what happens, and you don't need to remember all of this necessarily. I'm just giving you the why, okay? So an element like iron, for example. Okay, so iron, no, not green, red. So iron, if we draw its electron configuration, it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. All right? So, remember what I said the valence electrons are? What kind of electrons are the valence electrons typically? They're on the outside. What orbitals are the valence electrons usually in? It's either the S or the P, right? Or both, okay? So the outermost electrons for iron would be right here. Those are the valence electrons because those are the 4s electrons, all right? So if anyone asked, I don't know why someone would ask you, but, you know, if anyone just comes up on the street and says, quick, how many valence electrons does iron have? You know, I've kidnapped your mother. You have to answer this question correctly, or you'll never see her again. So now you can answer that question, right? I don't know why that hypothetical situation went downhill fast, but so you could tell them now, 2 valence electrons in iron, right? It's these 2 right here. Now here's what happens with iron. We call those the valence electrons because those are the ones that iron tends to lose first, okay? So iron can form a 2+ charge by giving away these 2 electrons. But if you think about it, how many d orbitals are there? How many? How many total d orbitals can you have in any given row? Not 6.
8.
Not 8. Go lower. You go higher than 4. There you go. 5. Okay. 5 d orbitals. Yes. Good job. Good job, class. Okay. So the 3d orbitals look like this, right? So iron, its normal electron configuration kind of looks like this. You know, you've got your 3ds and then you've got your 4 s's over here, right? So it makes sense, after it loses these and forms a 2+ charge, does it make sense that iron could also form a 3+ charge? What other electron might iron give away? Yeah. Because if it gives this one away, then it's got a half full set of d orbitals, and that's fairly stable, right? So this electron right here might also go away, so then you can also have iron form a 3+ charge. Either one of those is decently stable for iron, okay? So here's the problem. Most of the elements in the middle can do things like that. That means that you don't know, when I tell you iron, and let's say that I tell you iron chloride, okay? And I ask you to write the formula for iron chloride. Well, which iron is it going to be, right? Is the iron going to have a 2+ charge, or is it going to have a 3+ charge? I don't know. So any ideas what we maybe could do to fix that problem? No? Just put your hand up. You can't do that. Then I think you're answering the question. No ideas here? Well, but it's oh, you're talking about the anion, if it's more to the left or to the right. Yeah, it's not really going to depend on this so much, okay? Iron actually could form an ionic bond with chlorine where it has a 2+ charge. It can also form an ionic bond with chlorine when it has a 3+ charge. Both of those compounds actually exist, okay? So what we have to do it's this section again, right here. What we have to do is we have to somehow make a note of which iron we're talking about when we name this thing, okay? Now, the idea you come up with probably would not be the idea that chemists came up with because their system involves Roman numerals. I don't know why exactly Roman numerals. I guess they thought it looked better than just writing numbers there, okay? But I'll show you how that system works. But I just wanted you to understand why, okay? Because the transition metals can form more than one charge, so that's why we're doing this in the first place. We have to distinguish between them. All right, so here we go. Transition metals are located in groups 3 through 12. Most of these elements have 2 valence electrons. We already talked about that. I need to see where you have blanks. Elements that can have more than one possible charge must have a Roman numeral, okay? That was better. Okay, the Roman numeral is going to tell us the charge on the cation. Yeah. Okay, so the Roman numeral will tell us, do we have a 2+, 3+, do we have a 1+, or 2+? Okay, so there are certain elements that can have a 1+ or 2+, certain ones that can have a 2+ or a 3+, certain elements that can have a 2+ or a 4+. I don't expect you to memorize all of that, okay? But I do want you to understand how it works. So look down below on the chart that you already given, right? If it's copper 1+, then we call that the copper 1 ion. We just put a Roman numeral in parentheses that shows this is copper 1+ that we're talking about here, okay? Or the iron 2 ion if it's Fe2+. Same thing for over here, copper 2 ion or the iron 3 ion. Do you guys see how the Roman numerals match up with the charges? Okay, that's what the Roman numeral tells you. It tells you the charge on a transition metal. Okay, so it's really important that you understand that.
Will they just give you a Roman numeral?
Sometimes, yeah. If they're giving you the name, they will give you the Roman numeral. If they give you a formula and ask you to write the name, you have to write the Roman numeral when you're writing the name of the element. Okay, so that it makes it a little more complicated. All right. So the elements require Roman numerals because they can have more than one possible charge. We already kind of talked about that. So this is basically any metal except the 1A, group 1A elements, the group 2A elements, silver, zinc, cadmium, and aluminum. Okay? So you might circle that. You need to know that. Okay? Now, group 1 and group 2 is easy. Where are group 1 and group 2 on the periodic table? Yeah, first column and second column, right? So all of these elements, with the exception of the hydrogen, but even the hydrogen sometimes, but all of these elements are going to have what charge? Always a 1+. We know that, right? Okay, those always have a 1+. What about the group 2 elements? Always a 2+. What about aluminum? Always a 3+. Okay, so you've got those. The ones in the middle, we don't know, except for there are 3 exceptions, 3 ones in the middle that you actually do need to know. Okay, silver, 1+, cadmium, and zinc are both 2+. Okay, so it's these 3 right here that you just need to know they always have the same charge. Okay, and you don't really need to know why. I can explain it to you if you want to. It's based on the exceptions to their, well, either the exception for this one. What's that? Silver? Yeah, silver, cadmium, or zinc. Silver always has a 1 plus. Cadmium and zinc always have a 2 plus. Okay? All right, everything else, whoops. Did I unplug it? No. Okay. Everything else needs a Roman numeral. All right? So here's an example. If you've got FeCl3, that's the Fe3 plus ion, you would name that iron 3 chloride. Well, how in the world did we know that that was the iron 3 plus ion? Well, I said it was just now, but there's a way you can figure that out just by looking at the formula. You can sort of, see, I don't know. I don't like reverse crisscrossing because that can get you into trouble sometimes. It will work sometimes, all right? But notice this subscript down here. That's a 3, right? That probably came from up here and then crossed down here. Does that make sense? What's that? Well, okay, so if I had Fe2 plus here, then what would the formula be? FeCl2, okay? So based on the subscript, a lot of times you can tell, all right? Now, here's probably the better way to go about it, just to be on the safe side, because sometimes this will get you in trouble. You need to think about what charge does the chlorine have, because we always know the charge on chlorine, right? It's in group 17, so it's always going to be 1 minus, right? If there are 3 of those, each with a 1 minus charge, so I've got a chlorine, Cl minus, Cl minus, Cl minus, and this thing has to balance out so that it equals 0 when I add them together. What does the charge on my Fe have to be? Has to be a 3 plus. Does that make sense? Okay? I think that's the better way to think about it. It's not the easier way to think about it, but I think it's the better way because there are a couple of situations where this will get you in trouble. Let me give you an example. That's 10 SN. What's the charge on the 10 in that compound? Well, actually, tell you what, let me do this. Now what's the charge on the 10? You'd want to say 2 plus, wouldn't you? But here's the problem. What charge does oxygen have? 2 minus, and there's 2 of them, right? So what charge does the 10 actually have to balance out the 2 oxygens? It needs to be a 4 plus. Okay? See, that's where that reverse crisscross thing can get you into trouble, right? The subscript doesn't always equal the charge on this one. Sometimes it works, but I think this method is better because that will show you for sure. You just need to make sure, go with the one that you know, okay? The anion, you're always going to know the charge on the anion, and then figure out what charge your cation has to have in order to balance that out. Okay? All right. Let's do some more work here. Notes. Another example, CuCl, copper 1 chloride. Okay, where did the 1 come from?
Cl is a 1 minus.
Cl is a 1 minus. There's only one of them there, so the copper needs to be a 1 plus. Okay, you see how that works? You just kind of have to work backwards. Fn 4 plus, again, that one works where you reverse crisscross, but I wouldn't recommend it. Fluorine's a 1 minus. There are 4 of them, so the 10 has to be a 4 plus. So 10, 4 fluoride. You might have to brush up on your Roman numerals here a little bit. Everyone remember that IV is the Roman numeral for 4? Okay, and then V is for 5. Yeah, you shouldn't have to use 6 very often. You'll use 1 through 4 quite a bit. Okay, PbCl2, lead 2 chloride. Okay, because again, chlorine is a 1 minus, so the lead has to be a 2 plus to balance out the 2 chlorines that you have there. And then Fe2S3, iron 3 sulfide. Everybody okay with that one? That one's a little bit harder because you've got 2 subscripts, right? This is one where you've got a situation like this. It actually might be helpful to think about the reverse crisscross thing, right? When you've got 2 subscripts like this, that probably was a 3 to begin with. That was probably a 2 minus to begin with, right? 3 plus, 2 minus. So it can be helpful every once in a while. All right, everybody okay with that? That's a little tricky. It takes some additional thought. Okay, this says use the reverse crisscross method, but again, I think I took that off the notes because I wasn't super happy with that. But you can, that is a tool that you can use. You just have to be careful with it, all right? Check the charge on the anion. Where is this? Name the cation first. Okay, I guess what I didn't, okay. I took off these two things because these are both involving the reverse crisscross method, okay? So use the method that I showed you instead. I think that's better, okay? Name the cation first, then the anion second, just like we did before. Cation, the positively charged ion, always goes first. The anion always goes second. Cation, again, is just the name of the element, but this time it's the name of the element with the Roman numeral, okay? So you might say cation equals name of the element with Roman numeral, even though it doesn't say that on the notes, okay? Do you see where you're writing this? This is 3C on your notes. Underneath table 4.2. Okay, so the cation equals the name of the element, and again, I would put the name of the element with the Roman numeral. And then the anion, same as before, you just add IDE at the end for the anion. So that doesn't change. All right, where are we time-wise? Not a lot of time. Okay, so let's do a couple of examples here. And what I'm going to do is I'm going to give you a practice worksheet. Okay? Actually, let me hand out the worksheet now. And then we'll go over these examples because I want to make sure you have this. I will post the answer key for this tonight. I think what I'm going to do for tomorrow, I'll have an additional worksheet for you in class. So work on this tonight. Look at the answer key. We'll go over it again tomorrow, and we'll probably take the quiz at the very end of class tomorrow. That'll be kind of a nice break for us right before. Yeah, not a break. But, I mean, it'll be a good place to stop right before our break. Okay? So don't pack up yet because I want to show you at least one of these examples so that you know what you're doing for your homework tonight. All right. So complete the names of the following binary compounds with variable metal ions. That's just another way of saying transition metals. Yes. Oh, was I one short? Sorry. Okay, so FeBr2. What is Fe? Fe is iron, so we're going to put iron for sure. But then iron's in the middle, so we have to put a Roman numeral with it. What Roman numeral do I put here?
2.
Okay, because it's going to have a 2 plus charge. Now, how do we know that? Bromine is a 1 minus charge, right? Because it's in group 17. There are 2 of those. So if I have 2 bromines, each with a 1 minus charge, the iron needs to be a 2 plus charge to balance out the bromines. Okay, so this is iron 2. Then what? Bromide. Okay?
I don't get why there's 2 under bromine. Because it's like 1 minus and 1 minus.
Because there's 2 bromines there, right? So the total overall charge from the bromines is 2 minus, right? There's only 1 iron, so that 1 iron needs to be a 2 plus to balance out the 2 minus from the bromides. Okay? All right. The next one would be copper 1 chloride. Yep. Okay? So again, we'll go over more of this tomorrow to make sure you've got it before we take the quiz. But I would strongly recommend doing the practice problems tonight, because if you come into class and try to get it in the first 30 minutes, you might not still be there when you get to the quiz. Okay? And the quiz is going to happen the last 20 or so minutes of class.